will be more. And also whenever the light is traveling from the denser to the rarer, at that time how it will bend? Away from the normal, and the velocity will increases. The refractive index, nothing but what is the refractive index? The ratio of velocity of the light in the vacuum by velocity of light in the medium. So that we got that as mu is equals to, what is the formula? C by V. And after that we have discussed the relative refractive index. For example, if I say mu 21, what is the formula? Mu 21, mu 2 by mu 1. Mu 21 is equals to reciprocal of mu 12. And also the mu is directly proportional or otherwise inversely proportional to the velocity na? Inversely proportional to the velocity. Whenever it is becoming the denser, at that time velocity will decreases. Mu is inversely proportional to velocity, and that velocity is directly proportional to the wavelength. So only we got it as mu 2 by mu 1 is equals to V1 by V2, that is equals to lambda 1 by lambda 2. What is that lambda 1, lambda 2 are? Wavelength of light in the medium 1 divided by wavelength of light in medium 2. That is about the relative refractive index we have discussed. And refractive index of air is how much? 1 we have taken. And after that, whenever you see the refractive index is, for example, whenever I take the denser medium, then refractive index will be more as compared to the rarer medium. Based on that only velocity will either decreases or increases. That and all we have discussed about the introduction of this whatever the refraction we have discussed. And after that, Snell's law. Snell's law, what is the Snell's law statement? Mu and sin theta is always constant. So what I can write from one medium to another medium, nothing but mu 1 sin I is equals to mu 2 sin r. From that we got the ratio of sin I to sin r. Whenever the one of the medium is air, at that time what is the formula we got? Mu is equals to sin I by sin r. Then after that we have discussed about refraction through the plane surfaces. Before that we have discussed the refraction formula. What is the refraction formula? Mu 2 by V minus mu 1 by U is equals to mu 2 minus mu 1 by R. You have to remember this for the curved surfaces also, even for the lenses also. Okay, formula is important. Now I said plane surface. Plane surface nothing but R value becomes how much? Infinity. So mu 2 minus mu 1 by R becomes how much? 0. Then we got it as mu 1 by U is equals to mu 2 by V. Mu 1 is nothing but what? Refractive index of medium where object is placed. Mu 2 is nothing but other medium. Remaining medium is mu 2. U is what? Object distance or actual distance from where? From boundary. Correct? U is nothing but the object distance or actual distance from the boundary. Then V is nothing but the image distance or apparent distance from the boundary again. Based on that, we have solved two types of problems, that is whenever the object is kept in the denser medium and observed from the rarer medium. How it appears? Its depth is decreased or otherwise increased? Object is kept in the denser medium, nothing but swimming pool. Depth will decreases, it will come little bit up. So that shift we have found yesterday. And before the shift we have found the apparent distance. The apparent distance is equals to, what is the formula we got? Actual distance by mu, refractive index of the denser medium. Actual distance, that formula also important. The apparent distance is equals to actual distance by mu. And after that normal shift, otherwise apparent shift is equals to how much we got? X is equals to actual distance into 1 minus 1 by mu. That is about whenever the object is placed in the denser medium. And next one is whenever the object is placed in the rarer medium. At that time what happens? The height will be more than the actual height. Apparent height will be more than the actual height. There we got one relation for the apparent height. Apparent height is equals to actual height into mu. In multiplication we got for the second one. Then after that normal shift or apparent shift. X is equals to, what is the formula we got? H actual into mu minus 1. Mu minus 1 or 1 minus mu? Mu minus 1. That is about whenever the object is kept in either denser medium and rarer medium. And after that we have discussed the this one glass slab. Glass slab is there nothing but at that time what will be the normal shift or apparent shift. So whenever the glass slab is placed of thickness T, then what is the shift there? X is equals to T into 1 minus 1 by mu. This is same like the first one only I said, correct? Till there we have discussed yesterday. Now we will discuss the lateral shift. Lateral shift. Normal shift nothing but the shift was there in which direction? Shift was there either in the denser medium or in the rarer medium or in the glass slab. Shift was there in which direction? Perpendicular to the boundary. So only we said that shift as which shift? That is normal shift. Now this is a lateral shift nothing but it will not be in the perpendicular direction. So for that purpose I will take a glass slab of obviously thickness T. Now what happening means here this is one boundary and then this glass slab is having the refractive index is mu. Then here one ray is incidenting on the glass slab with angle of incidence I. Whenever the ray is entering from where to where? Rarer medium to denser medium. Automatically what happens? Towards the normal it will displaces, so that it is displacing or bending towards the normal. This is the angle of refraction. Diagram is very important to understand the problem here. So refraction is there in this direction. Then after that it is hitting the second boundary. Whenever it is hitting the second boundary, then what happening? It is coming again from which medium to which medium? Denser medium to rarer medium. Then what happens? It will bend away from the normal. So that away from the normal nothing but in this direction it is bending. So this angle of incidence is equals to this angle of refraction. Why? What is the reason? Medium is same. Very good. Medium is same here. This is also air medium only. This is also air medium only. So only here angle of incidence is I nothing but the angle of emergence also I only here. Clear? If this angle is R means automatically this angle also how much? R only. Now this is very important to understand that what is the lateral shift here. Lateral shift nothing but you just extend first incident ray. Whenever you extend the first incident ray, the final emergent ray and first incident ray will be parallel to each other. Are they parallel here? They are parallel. So the displacement between them is known as the lateral shift here. Clear? This is the x lateral. The just whenever you take the before first incident ray and then final emergence ray will be parallel to each other. The distance between them is known as the lateral shift. Why it is lateral shift? Why it is not normal shift nothing but it is not normal to the boundary. Normal to the boundary nothing but either in this direction or in this direction it should be there. But now it is not in normal, so only this is the lateral shift. That XL value I have to find. For that, listen here, I have taken this point is A here, point of incident is A, and then this point is B. Let me take, I want to get this XL means, shall I take this distance equals to this distance? X. I will take this as a point C. Why? Because I want to get the right angle triangle. So only I am just drawing that line extra. Then this angle is how much here? 90 degrees. Then here this angle is how much again? 90. I will take this point as D. What you have to find finally? XL, right? XL nothing but can I say BC? I have to find out the BC from this diagram. So how can you do that? Let's check here. This is a angle R means this angle will be how much? Tell me. Yes, very good. This total angle is how much here? I. This total angle also how much? I only obviously. If I remove only this much of angle means this will be how much here? I minus R. Clear? Now from the triangle ABC, right angle triangle ABC. From the right angle triangle ABC, sin I is equals to what? Sin I minus R, what I can write? Sin I minus R, what I can write? Which is opposite here? BC. Here angle is 90 degrees nothing but this will be the adjacent. Opposite, adjacent and then hypotenuse. So which is the hypotenuse here? AB is the hypotenuse. So sin I minus R is equals to opposite is BC, that divided by hypotenuse is AB. Now this is sin I minus R is equals to BC by AB we got. Now again what you will find nothing but I will find out the cos R. Cos R is equals to how much? Only R I am taking. R nothing but which triangle we have to observe? ADB triangle. So from the right angle triangle ADB, cos R is equals to which is adjacent here? AD is adjacent. See that this is the right angle triangle. Okay, so this is the adjacent, that is AD, that divided by who is hypotenuse here? AB. So that AB here. Then what you have to find out finally? BC, right? That is what the lateral shift for us. Now from this BC is equals to what I can write? AB into sin I minus R. Then BC is nothing but what? Lateral shift XL. That is equals to AB value is how much here? AB is equals to AD by cos R into sin I minus R. Then what is the AD? AD is nothing but what? Thickness of the glass only, right? T. So that T into sin I minus R by cos R. This is the lateral shift formula. Normal shift nothing but what is the formula? X is equals to, for the first case what we got? Actual depth into 1 minus 1 by mu. Only in terms of refractive index we got that formula. Now they have given about the angle of incidence and then angle of refraction. They have not given any mu here. There is no mu, nothing. They have not said that there is a glass slab, otherwise any other slab and all. So they are just giving the thickness of that medium, the denser medium. At that time T into sin I minus R by cos R. There is a formula for the lateral shift. It is not normal. What is the reason? It is not normal shift. What is the reason? The shift is not perpendicular to the boundary. Okay, if it is perpendicular, that will be the normal shift. We got already formulas. First case x1 is equals to d actual into 1 minus 1 by mu. Second case is equals to h actual into mu minus 1. These are the two formulas we got. If I have taken the glass slab of thickness T and refractive index, then what we got? X is equals to thickness into 1 minus 1 by mu. This is also same formula, this is also same formula, but when we have to use nothing but whenever they mention the refractive index and thickness, you have to use this formula, this shift formula. Whenever they mention angle of incidence and then angle of refraction and the thickness, at that time you have to use this formula. Clear? So this is lateral shift. Listen again, I will explain you the diagram properly. Now here I have taken the glass slab, otherwise any denser medium here. The denser medium of refractive index is how much? Mu. The light ray is entering from the air into the glass slab. Again from the glass slab it is coming out, emerging out. So this is the emergent ray, this is the incident ray. So here what happening? It is incidenting obviously with the angle of incidence I. This is the denser medium, so what happens? It will bend towards the normal, bending towards the normal in this way. Again here at this boundary, this is denser medium, this is rarer medium. Then what happens? It will bend away from the normal. So here I say I have taken that angle of incidence is equals to angle of emergence. What is the reason? Because same medium. Entering into the same medium, coming out with the same medium only. So same interface, by the way. The boundary is separating the same mediums. Here first boundary is separating the air and then glass. Second boundary is separating glass and then air. Both are same only. Both interfaces are same. So only we got the emergent ray with the same angle of incidence I only. Then after that, here angle of incidence, obviously this is angle of refraction. Then whenever I see the deviation, this will be the deviation actually. That deviation is how much? If this angle is I, means this angle also how much totally? I only. Then the remaining angle will be I minus R. For the simplicity sake, I have just given the names here A, B, C, D here. And now I have to find out the lateral shift. The lateral shift is exactly equals to what distance here? BC. So for that BC, I have taken sine angle, sine of I minus R for the first triangle. This is the right angle triangle, exactly like this it is there. This is the angle 90 and then this is point A and then B and then C here. And then this is what the I minus R angle. Then sin I minus R nothing but what will take? Sin theta is equals to opposite by hypotenuse. This is the opposite, this is the hypotenuse here. Why? Because this is a 90 degrees here. Adjacent, opposite and then hypotenuse. So opposite by hypotenuse BC by AB I have considered. And after that again I want to get the cos R. Why? Because I want to find out finally BC only, but I don't know the AB value. For that AB only I am taking the cos R again. See here, you can take either AB also, but this distance I don't know. I have to get the answer in terms of the thickness. Thickness nothing but I have to get AD, but I don't have AD here. For that purpose only I am taking the cos R here. So now again second right angle triangle, this one exactly like this it is there. Now this is ADB, this is angle 90. So cos R is equals to what I can say, adjacent by hypotenuse. Adjacent is what here, AD, hypotenuse is AB. So AD by AB I have taken, that is a cos R. Then whenever I just solve both, and then we got the lateral shift XL is equals to T sin into I minus R by cos R. This is one of the important formula. Clear? For the normal shift we have these three formulas. For the lateral shift only one formula is there. And also you have to mainly understand that at which cases we have to use which formula. Whenever they have not given any refractive index, blindly you go for this one. And then angle of incidence and then angle of refraction will be mentioned there. Clear? In this chapter particularly, if there are any critical difficult angles, for example 42 degrees, 36 degrees like that it is there, means they will give in the bracket. If they have not given, take in the approximation. Okay, you know 45, you know 60, you know 30, approximation you take. Copy that, lateral shift. The displacement of emergent ray with respect to the initial ray. In the next line, here angle of incidence is equals to the angle of emergence. Angle of incidence is equals to angle of emergence because the light is traveling between the same medium interface, same mediums interface. Copy that. Next one, lateral shift due to multiple slabs as well as multiple mediums, anything you can take. Yes, see that there we have discussed about only one slab. Here I have taken 3 slabs of different thicknesses and different refractive indexes. Now what happening, first ray is incidenting on the first boundary, then what happening, obviously it is entering from which medium to which medium here, rarer medium to denser. Then what happens, it will bend towards the normal. So it is bending towards the normal. Let me take As we are going down, we are having more thickness nothing but more refractive index. Okay, now again it is entering from the rarer to denser. Again what happens, it will bend towards the normal only. Here what I am saying nothing but I am saying that mu1 less than mu2 less than mu3, nothing but as compared to mu2, mu1 is rarer, as compared to mu3, mu2 is rarer. So here light is entering into the first boundary and then it is bending towards the normal with refraction how much, R1. Then after that it is entering into the second slab and then what happening, again bending towards the normal only. Good morning akka, good morning. Acha so ja re? So it is again bending towards the normal. Again next medium it is entering, again bending towards the normal. Finally it is coming out from the denser medium to rarer medium. So what happens, it will bend away from the normal. So it is bending away from the normal. Then I want to find out the total shift in this. So total shift nothing but I have to find out first of all each and every shift. So first shift is, I think I have written the numbers wrongly I think. First shift is this one only, right? This is x1. Second shift is this one x2 and third shift is this one x3. I want to get the total lateral shift. Window. I want to get the total lateral shift. What I have to do then? XL is equals to what? x1 plus x2 plus x3. So total lateral shift, that is XL is equals to x1 plus x2 plus x3. Already you know the lateral shift formula. What is that? Thickness into sin I minus R by cos R we will get. So that thickness of the first slab is how much here? T1 sin of I minus, first refraction angle is how much? R1. So that sin I minus R1 by cos how much? R1. Plus second one is T2 sin I minus R2 by cos R2 plus T3 into sin I minus R3 by cos R3. Clear? Multiple slabs, otherwise multiple denser mediums. Copy that. Yadi? Correct only, no?
I didn't get that.
What you are saying? X2 ke? Incident ray na? But with respect to the first incident ray only we will measure always. Yeah, what you are saying I understand. You are saying that for the second medium, first medium will be the incident ray, R1 will be the incident ray. No, we have to always take with respect to the incident, first incident angle only. Artha aita? First incident ray ne adi. What I said, the displacement between the emergent ray and then first incident ray. Any confusion in that? Clear, right? Some of the displacements only, that's it. Clear? Then next we will discuss the total internal reflection. Shall we do problems otherwise first? Yes? You want first total internal reflection or otherwise problems? Shall we discuss total internal reflection? After that together we will do the problems. Today it is not possible, I think. Today completely it will take for the total internal reflection only. You cannot remember the formulas, nothing but I will teach you the problems now only. However, easy problems only based on direct formula, that's it, nothing will be there. So far for the diffraction in the plane surface we got, first one about the normal shifts whenever we talk. In that whenever the object is placed in the denser medium and then viewing from the rarer medium. At that time, what is the normal shift we got? X is equals to d actual into 1 minus 1 by mu. And also in this, d apparent is equals to what? What is the formula? D actual divided by mu. Always you have to remember that. Okay, why? Because I said already the depth will decreases. Decreases means you just remember that we are dividing with the mu. Okay, don't confuse in that. And also I said that whenever the object is placed in the rarer medium, at that time what I said, height will get increases. Height will get increases, nothing but you have to multiply with mu. Clear? So the second case is whenever the object is placed in the rarer medium, h apparent is equals to what will get? H actual into mu. Because I said that height increases by mu times. Then after that, normal shift x is equals to h actual into mu minus 1. These are the 4 formulas which are useful in the shift problems. And after that, whenever I have taken the glass slab separately, at that time normal shift is equals to what will get? X normal is equals to thickness into 1 minus 1 by mu. Then after that, lateral shift. Lateral shift formula XL is equals to what is that we got? XL is equals to T into sin I minus R by sin R, cos R. Cos R. For the multiple mediums, you have to add the multiple values. That's it. Clear? This is what we have discussed so far. Based on this only, we will solve the problems. No tricky questions will be there. Directly formula based questions will come. The next one is total internal reflection. Total internal reflection. Total internal reflection. What is this total internal reflection means? Any idea about that? Perpendicular. That is a critical angle. See that whenever I have taken one light source here, otherwise one object here I kept, then what happening? Nothing but I am observing different incident rays. One is here, another is here, another is here, like that I am observing different incident rays. Why? Because it is not a laser, it cannot point only one point. Normal torchlight I have taken and then I am just making it to incident on the, always the source should be in the denser medium only. For the total internal reflection, source should be in the denser medium, that is the condition for that. Now, whenever I have taken the point source here, at that time I am getting one incident ray like this. With respect to the normal, what is the angle here? Angle of incidence is I. I said this is the denser medium, mu denser, and then this is the rarer medium. Whenever the light is entering from the denser to the rarer medium, then what happens? Away from the normal. In Pavitra chocolate beka? Chocolate tinta idra? Open madri, yellow sound barta ide. Etisha? Open. You can even show me and then you can eat. There is no problem. I will not tell anything. Eat and then listen the class at least. ಊಟ ಮಾಡ್ತಾರೆ ಡೈರೆಕ್ಟ್ ಬಾಕ್ಸ್ ಓಪನ್ ಮಾಡ್ಕೊಂಡು. ಸೊ ಹಿಯರ್ ಆ್ಯಂಗಲ್ ಆಫ್ ನಮ್ಮ ಬಾಕ್ಸ್ ನಾವು ಓಪನ್ ಮಾಡಬಾರ್ದು, ಬೇರೆಯವ್ರ ಬಾಕ್ಸ್ ಓಪನ್ ಮಾಡಬೇಕು. ಅವಾಗ ಟೇಸ್ಟ್ ಚೆನ್ನಾಗಿರುತ್ತಲ್ಲ. ಡೇ ಸ್ಕಾಲರ್ಸ್ ಅಂದರೆ ಹಾಸ್ಟೆಲರ್ಗೆ ಕೊಡಬೇಕು ಎಲ್ಲ ಬಾಕ್ಸಸ್ ಎಲ್ಲ ತಿನ್ನಾದ್ಮೇಲೆ, ಊಟ ಮಾಡಿದಾದ್ಮೇಲೆ ಖಾಲಿ ಬಾಕ್ಸಸ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದರೆ ಇವರು ಅವಲಕ್ಕಿ ತೊಗೊಂಬರ್ತಾರೆ ಅದರಲ್ಲಿ. ನೀವು ತಿಂದ್ರಂತ ಮತ್ತೆ 2 ದಿನ ಕಾಲೇಜ್ಗೆ ಬರಲ್ಲ. So here this is the angle of incidence, and I said that always source should be in which medium? Denser medium. That should be the condition for the total internal reflection. Then it is incidenting on the boundary with the angle of incidence I, and then it is moving from the denser to the rarer medium, so that what happens, it will bend away from the normal. That is the first ray I have observed. Then second ray I will take. The second ray is there like this. Again here angle of incidence is increasing or decreasing? Increasing, right? So whenever the angle of incidence is increasing, then what happens? Angle of refraction also increases only. So it is also increasing. Again it is coming more away from the normal. Let me take like that. This is I2, I will take I2 and then R2. Then again one more case I will take like this. Again what happening here? Angle of incidence is increasing more. So that what I will take here? This is I3. And for this I3, what should happen generally? Refraction should be, it should still bend right. It should be still away from the normal. At that time what happening? Nothing but it is coming like this. This is the angle of refraction. How much angle that is? 90 degrees. 90 degrees. Okay, fine. We got like that. Then next one, again one more ray is coming like this. Now this angle is I4, let us consider. Then what should happen? Again it should bend only again. It is bending into the same medium again. The light is bouncing back into the same medium. The phenomena is what? Reflection. Totally it is bending, totally it is bouncing back, so on it is total internal reflection. Internally in the same medium it is happening. Clear? That is a total internal reflection. And in this one special case is there, wherever the emergent ray, otherwise refractor ray, is perpendicular to the normal, that angle is known as what here? Critical angle theta c. So here this is a critical angle. At critical angle what happens? Nothing but the refractor ray will be exactly perpendicular to the normal. Clear? That is about the critical angle. Then this I4 is greater than the critical angle, otherwise less than the critical angle. Greater than. Whenever I increase, see that I1 is less than I2, is less than I3, is less than I4. Correct? So that see here I4 is greater than the critical angle. Nothing but the total internal reflection is whenever the incident ray is having the angle of incidence more than the critical angle, then what happens? The light will internally reflected totally. Clear? The incident ray is greater than the critical angle, then total internal reflection will occurs. If incident ray is exactly equals to the critical angle, then refraction will happen. How it will happen? Normal to the perpendicular to the normal. And in all the other cases it will be like normal cases only. Clear? So here whenever you see at the first ray, if I apply the Snell's law, what is the Snell's law states? Mu1 sin I is equals to mu2 sin R. So that mu1 is which one here? Mu d sin I is equals to mu r sin R. This is what the first case. If you take the third case, so what I can write? Mu d sin I3 is equals to mu r sin R3. Sin R3 value is how much? Sin 90 is how much? 1. So that this will be 1. If I consider the medium as, rarer medium as air, at that time again it is how much? 1 only. Then here sin in the place of I3 what I can write? Theta c, critical angle theta c. That sin theta c is equals to what we get here? 1 by mu d. This is the critical angle formula. And the total internal reflection means there is no formula for that, but the condition is what? To happen the total internal reflection, what should be the angle of incidence? More than the critical angle or less than the critical angle? More than critical angle. If it is less than critical angle, nothing but normal refraction will occurs. If it is greater than critical angle, nothing but total internal reflection will occurs. In this total internal reflection, we will have different applications. Varun, we will have different applications in total internal reflection. Beka beda? Okay, washroom ali malga. Challage ade alle cool iruttalla tumba AC tara. Enu Yuvaraja? Enu helta idralli? So here in total internal reflection different applications will be there. One is about the optical fibers, another is about the mirages, and about optical looming. Optical looming nothing but what happens? Any idea about that? Optical looming. In Iceland it will happen. For example, when a person is standing, at that time you will see the person's image in the air due to the total internal reflection. That is the optical looming. Okay? Avage now deva ankonde. No. At that time we will not remember any optics and all. Directly run only one run only. So for example, here one person is standing. At that time whenever I just look at another place, at that time I will find the image of this person there. That is not deva, that is optical looming. Okay na? So what Pramod, you are remembering anybody? There in the air. In the air you are remembering somebody, and then you are just remembering all the Madhura Smrutulu yalla. So that is the.
It's 12:23 p.m.
will get like this, it will be there, air density will become lesser whenever it is coming near to the earth surface. Why? Because due to the more heat. So at that time we will see some kind of forest, not forest, that is hills kind of things. Whenever you are just traveling on the tar road, you are just walking on the tar road without chappal, at that time you will find everything. At that time you will find everything there. So that is due to the mirages. And also we will find this one already you know that. On the tar roads you will find water kind of things, nothing will be there, yes. So that is by the this one on total internal reflection only, and also optical looming also, they also will come by the total internal reflection only, and also optical fibers. In optical fibers what happens, nothing but they will take a fiber wire. In the fiber wire they will send a signal. At that time due to the number of internal reflections, then light ray will travel. For example, if you are taking the light ray on the normal glass slab, for example, I have taken a big glass slab here, big glass cylinder I have taken. At one end I am just incidenting one light ray. Then what happens, I will get the emergent ray with the same intensity, different intensity, otherwise loss will be there, gain will be there. Loss will be there. Intensity will be lost whenever I just taken the emergent ray. But in the optical fiber what happens means, they will just make that wire as that completely whatever the ray I am just incidenting, that will completely internally reflected in number of times. So due to that number of times reflecting, there is no absorption of the light by the whatever the boundary we have taken. Why? Because they will just construct with the two mediums there, one is core, another is cladding, we will say. I will explain that however. So due to that two different mediums, the light will not come out, it will be travelling inside only by the number of refractions. Not lost, whatever the intensity we are sending, with the same intensity only we will get out. Clear? That is about the applications, different applications of the total internal reflection, even the diamond also. Whenever you see the diamond will be having more shine, it will have the sparkling because the structure of the diamond will be there like this. At each and every place that will find a plane surface. Due to that plane surface what happens, internally only it will undergo into the number of reflections. Due to that number of reflections we will see more sparkling of the diamond. These and all are the different applications of the whatever the total internal reflection, and also in that we will discuss about the optical fiber clearly. Okay, the remaining everything is theory only, but for the optical fiber one formula will be there, I will discuss that. Now total internal reflection, nothing but first of all you have to take always source and in which medium? Denser medium. From that denser medium we will take different incident rays. So first incident ray is there like this, and then refraction is there like this. Then after that it is obviously it is coming out from the denser medium to rarer, it will move away from the normal. It is moving away from the normal, first case. Then second case, again one more incident ray I considered in other place, where angle of incidence is more than the first angle of incidence. Again what happens, ray will bend, still it will bend away from the normal. So it is still bending away from the normal. After that again I just increase the angle of incidence, then it has to still bend. At that time what happening, nothing but it is bending to the 90 degrees exactly. That angle is known as what? Critical angle. That incident angle is known as the critical angle here. So that this is the critical angle I have taken, and then angle of refraction is how much here? 90. After that still I am just increasing the angle of incidence. It has to still bend only. Where it is bending, nothing but into the same medium again. So whenever the light is coming from the same medium and then going into the same medium, nothing but what phenomena, that is reflection. So here totally the light is bending here, so only this is a total internal reflection. Whenever the angle of incidence is greater than the critical angle, then light will bounce back into the same medium. That phenomena is known as the total internal reflection. If you consider at the first case and then second case, if you apply the Snell's law, mu d sin I is equals to mu r sin r. Obviously mu 1 sin I is equals to mu 2 sin r. Then we can get even the ratio of the mu r and then mu d also, and also here we will get the refraction angle also. Then after that here second case, not second case, third case I am taking, critical angle case. Whenever the angle of incidence is equals to the critical angle, then refraction angle is how much? 90 degrees to the normal. So here mu d sin I3 is equals to mu r sin R3. Sin R3 value is how much here? 90. Sin 90 is how much? 1. If I take the rarer medium as air, then sin theta c is equals to 1 by mu into mu denser medium we got. That is the critical angle. Now in this, one more formula will form. Let us consider this is a case mu d sin I is equals to mu r sin R. They have not given the mu r as air, they have given any other medium which is rarer as compared to this medium. Then here I can find out the refraction angle. Sometimes they will ask the refraction angle also. Then sin r is equals to what I can write? Sin r is equals to mu d by mu r into sin I. What is this mu d by mu r? Relative refractive index, mu 2 by mu 1, relative refractive index. So that what I can write here? Mu dr sin I. This is a sin r. I want to get only r, nothing but what I can write? Sin inverse of mu dr into sin I. This is a angle of refraction without total internal reflection. This is critical angle. And what happens? Refraction angle becomes how much? 90 degrees with respect to the normal. And after that, total internal reflection. In this case, we will get the deviation. We will discuss about, obviously, reflection nothing but what is the deviation? Reflection deviation. Delta is equals to 180 minus 2r, otherwise 2i, anything you can take. Write that first. For the total internal reflection, source object should be in the denser medium only. Should be in the denser medium only. Should be in the denser medium only. In the next line, as the ray moving from denser to the rarer medium, as the light ray moves from the denser medium to rarer medium, it will bend away from the normal. It will bend away from the normal. As we increase the incident angle, then refraction angle also increases. Refraction angle also increases. In the next line, you write critical angle. Keep the siding as critical angle. Critical angle. The incident angle at which angle of refraction is 90 degrees with respect to the normal drawn. 90 degrees with respect to the normal drawn. With respect to the normal drawn. Denoted by theta c. Denoted by theta c. Copy both the cases. After that, I will tell you the TIR. Just copy everything. Era Gautam. శ్రీవల్లి ఏమన్నా డాన్స్ వేస్తుందా? వచ్చి బెంచ్ మీద పడుకున్నావు. ನೀವು ಅನುವಾದ ಮಾಡ್ತಾಯಿದ್ದೀರಾ? ಅರೆ ಮನೋಜು, ಹೋಗಿ ವಾಟರ್ ಬಾಟಲ್ ತಗ ಬಾ. ಏನು ತರುಣ್ ಏನು ಮಾಡ್ತಾಯಿದ್ರು? ನೋಟ್ಸ್ ಬರ್ತಾಯಿದ್ದೀವಾ? ಆಲ್ರೆಡಿ ಬರೀದೀವಾ? ಯಾಕೆ ಇವಾಗ ಖಾಲಿ ಇರಬೇಕಾ? ನಿದ್ದೆ ಬರ್ತಾಯಿದೆ ಎಲ್ಲರಿಗೂ ಮತ್ತೆ? ಅರೆ ನಿದ್ದೆ ಬರ್ತಾಯಿದ್ದ ಹ್ಞೂ ಅನ್ನಬೇಕು, ಮತ್ತು ಚಾಕ್ಲೇಟ್ ಕೇಳಬೇಕು. ನಮ್ಮ ಉದಯ್ ಸರ್ ಕೊಡ್ತಾರೆ ಎಲ್ಲರಿಗೆ, ಪುಣ್ಯಾತ್ಮರವರು. ಅಷ್ಟು ಪುಣ್ಯವೆಲ್ಲ ನಿಮಗೆ ಆಗಬೇಕು, ಬರಬೇಕಪ್ಪ, ನೀವೇ ಕೊಡು. ಹಾಂ, ಪ್ರೊಡ್ಯೂಸರ್ ನಾನು, ಡಿಸ್ಟ್ರಿಬ್ಯೂಟರ್ ನೀವಾ? ಅವಾಗೆ ನಮ್ಮ ಸಿನಿಮಾ ಫೇಲ್ ಆಗುತ್ತೆ ಅವಾಗೆ. ರೈಟ್. ಹಾಂ, ರಿಲೀಸೇ ಆಗಲ್ಲ. ಫುಲ್ ಅಪ್ಸೆಟಲ್ಲಿದ್ದಾರಲ್ಲ. ಅಯ್ಯೋ, ಈಸ್ ಕ್ರೈಯಿಂಗ್ and then he is rubbing the hands like this. No, yesterday I have seen one scene there. No, actually everybody listen. You know, there was just all the boys were seeing that result there, and also that will be very smaller. Obviously, we have to get booth Kannadi to see that. And then this Pramod and then Shreyas, all the remaining boys were standing there. And then there in that crowd, Shreyas touched Pramod somewhere. At that time he said, "Hey, don't touch me, yaar." Yo, in public only people are doing like this, means what should happen? I don't know what happening in that bench. And you don't know how much, how his voice was. I just get shocked that who shouted like that. I asked and then everybody said that Pramod. I did not listen that kind of voice. By that feeling it will come, no? He's crying still, Papam. Missing him. Otherwise, shall I do the video call, Ray? At least then he will satisfy. And just take care where he gone. Somewhere from some other friend he gone or what, you just ask him. ಏನು ಮಾಡ್ತಾಯಿದ್ರಮ್ಮ ಮನೆಯಲ್ಲಿ ಅವರು? ನಿನ್ನೆಲ್ಲ ಪಾರ್ಟಿ ಮಾಡಿದ್ರ ಫುಲ್ಲು ಹಬ್ಬದೇ ಇವತ್ತಾ? ರೈಟ್. ನೆಕ್ಸ್ಟ್ ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್. ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಹೂ ಇಸ್ ದಟ್ ರೇ? ಇಲ್ಲ, ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಡೆಫಿನೇಷನ್ ನಾನು ಪ್ರಮೋದ್ಗೆ ಶ್ರೇಯಸ್ಗೆ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡು ಎಲ್ಲ ಮರ್ತು ಬಿಡ್ತಾ ಇದ್ದೀನಿ. ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್, when the angle of incidence is greater than the critical angle, when angle of incidence is greater than the critical angle, then light ray will bounce back into the same medium. Light ray will bounce back into the same medium. Bounce back into the same medium. This phenomena is known as total internal reflection. This phenomena is known as total internal reflection. This phenomena is known as total internal reflection. See that if this medium is not air medium, mu r is not air, at that time what will get sin theta c? If mu r is not air medium, then what will get sin theta c is equals to mu r by mu d. Again what I can write this one as sin theta c is equals to, can I write it as 1 by mu dr? Mu d r nothing but what? Mu d by mu r. But what we are having here? Mu r by mu d, so that I can write it as 1 by mu dr. Always you just remember that sin theta c is inversely proportional to mu d, mu. Then next, write a problem. Find Find, first question in that, find angle of deviation, find angle of deviation when angle of incidence is less than the critical angle, less than the critical angle. Next question.
It's 12:39 p.m.
If angle of incidence is greater than the critical angle. So in that first case is whenever angle of incidence is less than the critical angle, then what happens? As usual, refraction only. So that this is angle of incidence I will take, and then this is angle of refraction R I will take. Then already we got the R formula. What is that? R is equals to sin inverse of mu d by mu r into sin I. For example, let us consider this is the air medium. Then mu r value is how much here? 1. Then mu d will be there as it is. You have to find out the angle of deviation. Angle of deviation means how to take the angle of deviation. You have to take first of all incident ray, and then this angle is known as the angle of deviation. That angle of deviation is how much here? Can you tell me that? Delta in terms of I and R is how much?
R minus.
See that this is how much here? If this is I means this is also how much? I only. Now can I write this as I, what is that? You have to get the delta, right? R is equals to I plus delta. Correct? R is equals to I plus delta. Then delta is equals to what I can write? I minus R. R minus I. R minus I. Right? You people disturbed me, right? Huh? Hey, R is equals to I plus delta. That is what I have written here. Num language ali the delta. Matte nimdu different language alla. R is equals to I plus delta, no, right? What is the confusion there? So delta is equals to R minus I. Now I want to find out this delta only. For finding the delta, first of all I will apply the Snell's law here. Mu d sin I is equals to what I can write? Mu r sin r. Mu r value is how much here? 1. Then sin r is equals to what I can write? Mu sin I. Then r is equals to sin inverse of mu sin I. Anything wrong? Correct only, na? Sin inverse of mu sin I. This is what the R we got. Then delta is equals to what I can write? Deviation. Deviation. Delta is equals to what I can write? R minus I, nothing but sin inverse of mu sin I minus I. This is the formula of deviation, and there is no need to feel difficult to remember this one. There is no need to remember also, by the way. By the derivation only you will get that. If you remember also, you will get confused there. You will remember the wrong formula. And I think in by-hearting, you people are not poor like me. You will by-heart everything. Already by-hearting biology. No, re? Without logic, how I don't know how you people will read it. Who is Medhavi in biology in this class? Population chapter you will get in zoology. Population will be there. Special chapter for him only. Multiple wives and then multiple children. Innu children plan madilalla. Matte Shreyas and Yatish nimden plan. ನಾವಿಬ್ಬರು ನಮಗೆ ಇಬ್ಬರುನಾ ಇನ್ ತೆಲುಗು ಒಂದು ಸ್ಲೋಗನ್ ವಿಲ್ ಬಿ ದೇರ್ ಮೇಮಿద్దರು ಮಾಕಿದ್ದರು ಅಂದರೆ ನಾವು ಇಬ್ಬರು ನಮಗೆ ಇಬ್ಬರು అని ಶ್ರೇಯಸ್ಗೆ ಇಬ್ಬರು ಇದ್ರೆ ಫಸ್ಟ್ ಇಬ್ಬರಿಬ್ಬರಿಗೆ ಇಬ್ಬರಿಬ್ಬರು ಅಂದರೆ 4 ಮೆಂಬರ್ಸ್ ಆಗ್ತಾರೆ. ಯಾರೋ ಸತ್ಯಂ Now this is the object we have kept, and then now angle of incidence is greater than the critical angle. Greater than critical angle means what happens immediately? Total internal reflection. So that angle of incidence is there like this, and then the ray is reflecting back into the same medium. This is angle of incidence I, nothing but this will be what? Reflection, right? Angle of incidence is equals to angle of refraction. That is what the law of reflections. So that this is also how much I can take? I only again. You understand? In the plane mirror we have taken that I is equals to R. Angle of I is equals to angle of R. The same thing only here also. So this is I means this is also I only. Now you have to find out the deviation. Very good. See that deviation is nothing but this is the incident ray and then this is the deviation angle. The deviation angle is equals to how much? Already we know the formula already for the reflection. Delta is equals to what is the formula? 180 minus 2i. That's it. 180 minus 2i. This is totally how much angle? 180 minus 2i gives you the delta. Second one is easy only. Next, applications of total internal reflection. Applications of total internal reflection. First one, mirages in deserts. Mirages in deserts. Second one, right, directly you know the theory already. What you will see by using the total internal reflection only, we will see the water. Without water only, you will see the water. Next one is optical looming. Optical looming. In Iceland, you write in bracket. Write Deva example. Next, third one is diamond, sparkling of diamond. Sparkling of diamond. Sparkling of diamond. Then last one is optical fiber. Sparkling of diamond. Next,
Sorry, I didn't
optical
get that.
fiber. We'll see the optical fiber. I said always source should be where? Denser medium. Completely theory, only one formula will be there in this. So here I have taken an optical fiber wire like this. So this is optical fiber wire I have taken. In this, two layers will be there. One is normal electrical wire only, you just assume. Inside one layer will be there, that is a copper wire will be there. Outside what will be there? Shield will be there. Like that, in the same way. Here also for this, we will say that one layer will be there. Okay, still 10 minutes time is there, wait. This one is known as cladding. The outside cover is known as the cladding. The inner one is known as the core. Core and then cladding. And also this core will have the refractive index of mu1. The cladding will have the refractive index of mu2. Then here what happens? Nothing but whenever I send one light ray into the optical fiber, here always mu1 greater than mu2. Nothing but core density will be more than the cladding density. Nothing but core will be the denser medium and then cladding will be the rarer medium. Just outside surface only, that is. Then what happening? Nothing but I am sending the light ray into the optical fiber like this. I am just incidenting a light ray here. Then what happens? It will go and then hit the boundary here. That boundary is separating which mediums here? Core and then cladding only, right? The inner one is core and then outer one is a cladding. So here this will incident in such a way that the incident angle is greater than the critical angle. This angle of I is greater than the critical angle. If it is greater than critical angle, then what happens? Total internal reflection. So that the light ray will reflect into the same medium again in this way. Now again it will hit the again other boundary, again angle of incidence is greater than the critical angle.
It's
Internal
12:49
reflection
p.m.
only, it will go back into the same medium again. If this angle of incidence is less than theta c, then what happens? Where the light ray will come? Outside. Outside. It is just fiber only. This is like glass only. Okay. That is a transparent medium only. Whenever you see, you take the optical fiber, you can see the other side object from here also. So that is just transparent medium only. But what happens? Nothing but it will be constructed in such a way that the core will have more refractive index as compared to the cladding. So, and also the angle of incidence will be there in such a way that it is greater than the critical angle. So, here greater than the critical angle, so it is going under TIR, and then again TIR, again the angle of incidence is greater than the critical angle only, again total internal reflection, again total internal reflection, like this it will come out. And also after coming out, how it will come? It will come into the same path, otherwise it deviates. Coming from fiber to the air. Fiber to the air. Fiber is what here? Denser medium. Air is a rarer medium. It will move away from the normal. Here also the same thing will happen, I am sorry. Towards the normal, no? So like this it will fall. Okay, this is what the total internal reflection in the case of optical fiber. Optical fiber nothing but that is just like a glass only. That will be already, you know, fiber material already. That is what the optical fiber here. By that only, by using that only, they will make the optical fiber wires. And that will be the completely transparent medium. In that, if you are incidenting a light ray which is less than the critical angle, nothing but obviously it will refracted out. It will reflected out, and then we will see that. Then here, we are just making that angle of incidence is greater than the critical angle. Then what happens? Nothing but it will just undergo the total internal reflection, and that too for the total internal reflection the core density should be nothing but the refractive index of the core should be greater than the cladding. Why it should happen? Why it should be like that? Optical fiber is constructed in such a way that core refractive index should be greater than the cladding refractive index. What is the reason? Yes. For the total internal reflection, what should happen? The source should be placed in the denser medium. So, this is the source here. This first ray is the source. This is the source here. That source should place in the denser medium only. So, only the core refractive index is more than the cladding refractive index. Now, I am just incidenting the ray. For example, I am just incidenting in this direction. Then what happens? In this direction I am incidenting in this direction. Then what happens? TIR will not happen. It will come out like this. Correct? So, here what happening? Nothing but I am just incidenting that theta, it is angle of incidence is greater than the theta c. Then total internal reflection will happen in the number of times. Finally, we will get the same intensity light only. Why same intensity light? Nothing but completely it is reflecting. It is reflecting nothing but there is no absorption of light by the cladding. If there is any absorption is there, nothing but at that time what happens? Energy gets wasted, intensity will become less. Now intensity is not becoming less. Why? Because the cladding is not absorbing. Not absorbing because it is reflecting. For example, if you are taking the mirror in front of you, with whatever the intensity your light rays are going, with the same intensity it will come back. What is the reason? Why? Because mirror is not absorbing anything. For example, you are incidenting the light ray on the wall. At that time what happens? The less intensity we will get. What is the reason? Wall will absorb the light. Clear? Now you cannot say that wall does not absorb. For example, if you are just making the light to fall on the white wall, at that time the intensity will be more. Whenever you are making the light to fall on the blue wall, otherwise black wall, at that time reflecting intensity will be less only. Why? Because absorption changes there. Clear? That is about the total internal this one optical fiber mechanism, and I will tell you the formula also. Write the theory first. Optical fiber made with the optical fiber made with the transparent fiber in two layers in such a way that the inner layer, that is core, will have more refractive index as compared to the outer layer.
It's 12:54 p.m.
Outer layer, that is cladding. The next line, in optical fiber, the incident ray will enter into the core and hits the boundary between the core and cladding in such a way that the angle of incidence greater than the critical angle. Angle of incidence greater than the critical angle. Then TIR occurs. Again incident angle on the other boundary greater than the critical angle. Again TIR. And so on. The next line, very important point. There is no absorption of light by the cladding. So intensity will be same between the incident and emergent ray. See that only one formula will be there here. For getting the total internal reflection in the optical fiber, one fixed formula directly will write that is the incident angle sin I should be less than or equals to under root mu1 square minus mu2 square. What is this mu1 and then mu2? Mu1 is nothing but what? The refractive index of core, and mu2 is refractive index of the cladding. So the sin I, the angle of incidence should be less than or equals to under root mu1 square minus mu2 square. Then only total internal reflection will occur in case of optical fiber. That is the formula, one formula only.
It's 12:58 p.m.
Circular illuminance of light when source is placed in the water. If you see that Discovery Channel, in that whenever they are just showing the view of the shark, At that time what they will show? For example, the shark is viewing into the sky from the water, then how it will look, and then whenever in that only they might be shown a number of times that in whenever you see the blue world channel like that, in that you can get that whenever they are just placing one object, otherwise one light source in the water, how it will come out, how it will come out, in which shape it will come out, like this circular shape. It will forms the circular shape on the water surface. Have you ever observed that? In some of the cameras also, in Discovery Channel cameras also, it will show in which shape, nothing but only in the circular shape only. So that is what the circular illuminance of the light on the water surface whenever the source is placed in the whatever the water. So now you have to find out that area. I will show you that videos also, if you want, in the Discovery Channel it will be there. So whenever the, for example, shark is there inside of the water, that shark is looking outside world. At that time, how the view of the shark will be there, nothing but the view of the shark will not be there in the plane, it will be there in this direction, nothing but on the surface it will form the circular shape. That area you have to find out. For example, I have taken the torch light under the water, under the sea I have taken. So if I am taking under the sea with less height, less depth, at that time I will see more area. If I am going more in depth, at that time what I will see? I will see the less area. So for example, if you people also while swimming, if you are just going not in the swimming pools, in the rivers, whenever you are swimming, at that time you are going much deeper into the water. If the water is crystal clear, at that time you are seeing the outside world, nothing but your view will be the circular view only. Even you want means you can do that experiment once you know the swimming. Okay. And after that, don't put murder case on me. Still so much life I have. Madhe kuda agilla inu. Ayyo paapam. So here that circular area you have to find out. I will just give you a hint and then you have to solve that problem. If you not get the answer, I will tell you. Now here I have taken the water surface and then here inside of the water I kept a torch light. ಇಷ್ಟು ಭಯಂಕರమైన ಟಾರ್ಚ್ ಲೈಟ್ ಎಲ್ಲಿ ಇರಲ್ಲ ವರ್ಲ್ಡಲ್ಲಿ. So here this is the angle of incidence. That angle of incidence is exactly equals to the critical angle. Exactly equals to critical angle means what happens? Greater than 90 or equals to 90? Equals to 90 ಯುವರಾಜ. ಏನೋ ಯೋಚನೆ ಮಾಡ್ತಾಯಿದ್ರು, ಫುಲ್ ಡೀಪಾಗಿ ಯೋಚನೆ ಮಾಡ್ತಾಯಿದ್ರು. Angle of incidence, and then this is also here angle of incidence only. This will be the critical angle. Obviously this is equals to theta c here. And not only two rays, the rays will be there in all the directions. So what I can do, nothing but here I can form a circular shape. This distance of the light is h, let us consider, and then this distance is r here. If this angle of incidence is I, nothing but this angle also how much? I only. That I is equals to exactly how much? Theta c, and the denser medium is having the refractive index is mu. You have to find out the area of this one, otherwise at least you find out the radius. Try that, okay na? Chalo, go for lunch. H cos theta. What is that cos theta value? Cos theta is equals to what? Adjacent by hypotenuse, no? Adjacent by hypotenuse, no? You have to take tan. Adjacent by hypotenuse andre h divided by hypotenuse. Hypotenuse ಎಷ್ಟು ಬರುತ್ತೆ? under root h square plus r square. In terms of mu you have to get the answer. ಆಯ್ತಾ ಲಂಚ್ ಟೈಮ್? ಚಲೋ ಆಫ್ ಮಾಡಮ್ಮ ಸ್ವಲ್ಪ.